Hey guys, second year kids, good morning. We're gonna continue on this chapter. I'm not sure exactly where we left off yesterday. I think we just did the first 5 questions, so we're gonna do the second 5. So um, this will be part 2, actually chapter 1 AC theory, part 2. Section. So we left off yesterday at the 240 and the 10 ohm resistor. Today we're going to talk about current in an AC circuit. What role does inductance play? Okay, so we want to know what role inductance plays in a circuit. So the inductance is the creation of voltage due to it has to do with time, and a variance of current. Also, it's the opposition to current change, causing current to lag or lead behind voltage changes. It's the unit. So inductance is measured in a Henry. All right. So if we have when we come out of when we have voltage and current, if we have a purely resistive circuit, voltage and current will run together. They'll run in phase together. As soon as we have a inductive circuit, okay, voltage will lead and current will lag behind. Okay, current will lag behind because you're creating, it's an inductive circuit which is causing a resistance based on time of current. So it's a created resistance inside the line, and it's causing current to lag behind, and now the voltage is kind of pulling it along. So that's called lagging. The current is lagging the voltage. You got to think of these two words. One's called LE and one's called ICE. LE is voltage leading current, okay, E before I, voltage leading current. ICE is current leading voltage, right? Current I, C for capacitance, E for voltage, okay? So that's a capacitive circuit. Current always leads in a capacitive circuit. A capacitive circuit is a little bit different. So a capacitance is a built-up of power, and it gives you an opposition of voltage, opposition for voltage to, it creates an opposition for voltage, all right? So LE is voltage leading current. Okay, that means there's inductance. L in the middle is the letter for inductance. So L, inductance, voltage leading current. ICE is a capacitive circuit because C is for capacitive. That's in the center. So try to keep those two things in mind. So if you've got a purely capacitive circuit, current is just flowing along and voltage is just pushing it, and it's all good. If you got an inductive circuit, then you got a resistance, and kind of related to that water thing again. Now you got that sprayer on the end of the hose. You're getting a lot of pressure, but you're only getting a lot of current. So the pressure is up there trying to pull it out now, and then your current flow is being restricted. All right, guys, I'm back. So the second thing we're going to talk about, when current increases in AC circuit, what role does inductance play? Okay, so inductance plays what role? It reduces the current. It stops the current. It reduces it. So that is the role that inductance plays with current. Okay. All right. So question number 2, we're going to talk about which of the following coils is likely to show the lowest inductance. Coils. So think of a transformer. So we get coils with a lot of turns a coil with a magnetic core, a coil with a narrow core, a coil with a short core. Okay, so a coil with many turns is going to show a high inductance. A coil with a magnetic core is probably going to show a good amount of inductance. A coil with a short core will probably have a decent, but a coil with a narrow core is going to be your lowest reductance. So a coil with a small core in the middle will have the lowest amount of inductance, and this probably has to do with transformer based. So you just got to think about what large cores, better metal, tighter wrap, more wraps, higher inductance. Less smaller cores, thin long cores, it's going to create an inductance. Short core, it's not going to create as much of an inductance. Number 8, which of the following conditions exist in a pure inductive circuit? What if it's purely inductive? Which of the following conditions exist? All right, so are the voltage, so if it's a purely inductive circuit, the voltage and the current are 90 degrees out of phase. If it's purely resistive circuit, the voltage and the conductor are 90 degrees, are the voltage and the current is in phase. They run with each other. As soon as you create an inductive current, what happens? The current lags behind the voltage, and now the voltage is leading and you're 90 degrees out of the phase. If you went the other way with capacitance, current would go into the lead and you would have just the opposite. So when an purely inductive circuit, voltage and current are 90 degrees out of phase with the voltage leading. Reactance increases with an increase of what? Reactance. What is reactance, guys? So reactance, I'll give you the actual definition. It is the opposition of alternating current due to capacitance. So we have capacitance and or inductance. AC capacitance or inductance. It's the opposition to alternating current. It's the opposite of the alternating current. So it's something that reacts. So reactance increases with the increase of inductance. So the more inductance you have, the more it reacts. So the more you have an opposition to the current. Okay. Reactance, you have capacitive reactance and you have inductive reactance. So reactance increases with an increase in inductance. If you have an increase in capacitance, the reactance will decrease. Okay. Capacitance, last question. Capacitance is measured in what? What do we measure capacitance in? Amps, henries, joules, or farads? Farads. Farads, F is how we measure the amount of capacitance. When you see a capacitor, you'll see F 200 or whatever. That's going to be the measurement of a capacitor. It's measured in F. So questions are this. Question number 6. When the current increases in an AC circuit, what role does inductance play? Inductance, does it increase the current? Does it play no role at all? Does it increase the overcurrent protection, or does it reduce the current? Okay. Number 7, which of the following coils is likely to show the lowest inductance? A coil with many turns, B, a coil with a magnetic core, C, a coil with a narrow core coil, or D, a coil with a short core. Narrow coil. 8, which of the following conditions exist in the circuit of pure inductance? A, the voltage and the current are in phase. B, the voltage and the current are 90 degrees out of phase. C, the voltage and the current are 120 degrees out of phase. D, the voltage and the current are 180 degrees out of phase. 9, Reactance increases with an increase in what? A, capacitance, B, inductance, C, magnetism, D, resistance. Where does it increase? With inductance, capacitance, inductance, magnetism, or resistance. And 10, capacitance is measured in what? A, farads, B, joules, C, henries, D, amps. Okay, guys, that's it. You can go back through. All the answers are there. Sorry it was a little confusing. I got a little distracted here. Forgot my glasses. It's hard to see in this light, so I'm struggling a little bit today. But we'll talk more about the capacitance and the reactance and the inductance when we get a little more time, so you guys understand it a little bit better. I know this was a while ago. We did this at the beginning of the year, so we got to get it kind of when we were in a PowerPoint. It was a little easier. So, well, we'll talk about it more. This is just your baseline of electricity. Have a good day. I'll see you guys tomorrow.